On this slide, we talk about canonical bundle on Pn. Now this will be important for discussing Serre duality, and we just will see that canonical bundle on Pn is nothing but O minus n minus 1. So for this you need to recall the sheaf of differential forms. So let us start with the rational section of Kpn. So just see the slide on sheaf of differential forms before you start looking this up. So obviously the natural open sets of Pn are An, and then we have this dx1 exterior product, dx2 exterior product all the way to dxn. And these An are nothing but standard open sets of Pn. And this function f is a regular function of An. This f x1 comma x2 all the way to xn is a regular function of An. So now you consider this rational section omega. Now you can clearly see that every one of these has a pole of order 1. Yeah, on x1 equal to 0, x2 equal to 0, x3 equal to 0, and so on. We want to find out the divisor for this omega. Now again we are working on an open set, the standard open set of Pn. So in order to find the divisor of omega, we need to find out the order of each of these xi's. So we want to find first the order of x0 equals to 0. So first of all, you write omega in coordinates of An. So in this case we just put y1 as 1. We have to set one of the coordinates as 1, so we just pick arbitrarily, divide throughout by y0. And 1 by y0 you say is x1, y2 by y0 is x2, and then yn by y0 is xn. Now you can rewrite omega as d of log x1 exterior product d of log x2 exterior product d of log xn. Yeah, so we are just rewriting, because d of log x1 is nothing but dx1 by x1 and standard. Now instead of x1 I'm writing 1 by y0, instead of x2 I'm writing y2 by y0, instead of xn I'm writing yn by y0. Now we just use the properties of the log. So I should be writing d log of f divided by g. D log of f divided by g is d log f minus d log g. So yeah, y2 by y0 you're writing d log y2 minus d log y0 all the way to d of log yn minus d of log y0. So since repeated terms cancel each other in the exterior product, we get minus d of log y0 d log of y2 all the way to d log of yn. Divided by y0 y2 all the way to y3 all the way to yn. Now notice that in the denominator you have n terms. Yeah, one is missing, so that is why you have n terms, and you are working on this open set. So you can clearly see, if you take into the account the open set also, you will have O minus n minus 1 as the canonical form, or you can say your divisor of omega is minus. Now you take all the hyperplanes including the one on which you were working, so you get these n plus 1 hyperplanes which are corresponding to these this product in the denominator. So you can clearly see now this is the sum of n plus 1 hyperplanes, and you have a minus sign in front of it. More importantly, you see that everything is in the denominator. So this looks like O minus n minus 1. So we can see this from here also. So in denominator we have these n factors, and then you have the corresponding open set.